We have a hardware problem in 2026. Massive artificial intelligence models are splintering the strict physical limitations of consumer hardware. Open-weight models now match the reasoning of proprietary giants. You can download graduate-level intelligence directly to a standard hard drive. But forcing a 13 billion parameter model onto a budget laptop triggers severe system crashes, frozen applications, and forced reboots. Local AI deployment has evolved beyond picking the smartest model at the top of a leaderboard. To get these tools to function, you have to master VRAM math and constraint management. Successful deployment depends entirely on the math required to match a model's digital footprint to your machine's strict physical limits. This chart represents a standard 8 GB laptop's memory, revealing a mathematical illusion. Your operating system immediately claims 2 GB. Open a web browser or code editor, losing another 2. You're left with a tiny 3 to 5 GB budget for your AI model. If you load a model that exceeds that green sliver, your computer hits what's called a swap storm. It runs out of physical memory and is forced to use your slow, mechanical hard drive as RAM. In a swap storm, your generation speeds plummet to a maximum of 1 to 3 tokens per second. Survival on an 8 GB machine requires you to optimize your software stack and abandon the idea of running massive general-purpose models. Optimizing your local pipeline starts with the software layer you use to run the model. Consider Ollama. It operates as a headless, terminal-based daemon. Because it lacks a heavy graphical interface, Ollama preserves maximum RAM. Paired with a minimalist front-end like Chatbox, it serves as the ideal choice for budget hardware. On the other end of the spectrum is LM Studio 0.4.0. This is the heavy-duty option if you have hardware overhead to spare. This diagram illustrates continuous batching. Instead of forcing requests to wait in a sequential queue, LM Studio processes multiple parallel requests simultaneously through a single model. It also includes stateful REST APIs to power complex, multi-step agent workflows entirely on your local machine. LM Studio's advanced graphical interface and parallel features carry a significantly higher baseline memory footprint. On 8 GB machines, this overhead creates a high risk of immediate crashes. Use LM Studio for multi-agent power if you have the RAM, but default to headless Ollama for strict memory preservation. After choosing your software layer, you must immediately apply mathematical compression, or quantization, to make the model fit properly. Attempting to run uncompressed 16-bit models, or even 8-bit versions of 7 billion parameter models, will immediately consume your entire 8 GB memory pool. This graph shows why 4-bit quantization, specifically the Q4KM format, is the exact sweet spot. The model size drops significantly right here, while the reasoning quality remains stable. Through this compression, a 7 billion parameter model shrinks from 8 GB down to roughly 4.5 GB. Compressing further to a 2-bit level saves more space, but it fundamentally breaks the model's internal logic and response quality. Q4 quantization sacrifices a fractional edge in highly complex multi-step logical reasoning compared to uncompressed models. Despite that edge case, Q4KM is the non-negotiable standard for local deployment. In practice, a smaller model with proper quantization almost always outperforms a larger model that is rapidly choking your system. Hardware constraints mean you cannot rely on a single massive model to perform every task. Instead, you must select specialized architectures. For coding, math, and heavy logic, use DeepSeek R1 8B. This model improves accuracy by breaking problems down into internal steps before providing an answer. This powerful reasoning capability consumes almost your entire 5 GB available budget and introduces noticeable generation latency while the model thinks. If you need to analyze images or transcribe audio, you must swap to a multimodal small language model like Gemma 3N or Qwen 3.5. Feeding dense audio waves and high-resolution visual data into a local system will rapidly flood your tightly constrained processing stream. Processing these media files devours your model's context window much faster than plain text, requiring aggressive prompt chunking to maintain performance. Successful deployment on limited hardware requires matching the architecture of the model to the specific requirements of your current task. For the budget coder running a standard 8 GB Windows or Intel machine, the strategy is specific. You should use terminal-based Ollama paired with a sub-4 billion parameter model like 5.4 Mini or Qwen 2.5 Coder 3B in Q4. If you single-task and close all background apps, you can expect 8 to 10 tokens per second for fast autocompletes. The Prosumer segment, users with 16 gigabytes of RAM, Apple M-series chips, or discrete graphics cards, has a different mathematical reality. Apple's unified memory, or an 8 gigabyte VRAM card, pushes generation speeds up to 40 tokens per second. With that headroom, you can comfortably deploy LM Studio 0.4.0, utilize continuous batching, and run heavier 8 billion parameter reasoning models. Transitioning from shared RAM to 16 gigabytes or a discrete GPU is the single highest return on investment hardware leap available for local AI. The enterprise deployer operates entirely outside the boundaries of consumer laptops. This segment targets massive open-weight systems like the 400 billion parameter Llama 4 Maverick or DeepSeek V3.2. These organizations use platforms like Onyx AI or headless LLMs daemons to manage deployments across high-density GPU clusters. Even with 4-bit quantization, these models require well over 100 gigabytes of dedicated VRAM. That infrastructure cost provides GPQA Diamond graduate-level reasoning while maintaining absolute data sovereignty for the organization. Both the 400 billion parameter model on a server and the 3 billion parameter model on a laptop serve crucial functions. Whether you are tinkering on a $300 laptop or managing a $300,000 server rack, your intelligence ceiling is strictly governed by how perfectly you match the model to the hardware's mathematical limits.